Now in this lecture we study some rules of differentiation, and by using these rules of differentiation we try to find the derivatives of complicated functions. Okay, so let us take first rule of differentiation, and that rule is called as the derivative of a scalar multiplication. Derivative of scalar multiplication. Derivative of scalar multiplication. Derivative of scalar multiplication. So we state this rule here now. If u is a differentiable function of x, if u is a differentiable function of x, and if y is equal to ku, where k is constant, then our rule is derivative of y with respect to x is equal to k times derivative of u with respect to x. So this is the simple rule of differentiation. Okay, first rule of differentiation. If y is equal to ku, see here, if y is equal to ku, then its derivative dy by dx is equal to k times derivative of function u, okay, with respect to x. So this is our first rule of differentiation. Now we go to the second rule. So this rule is called a scalar multiplication. Okay, now go to the second rule of differentiation. Rule to derivative of sum. Derivative of sum. Okay, if u and v are differentiable functions of x, and if y is equal to u plus v, then we write the derivative of y with respect to x. Okay, if u and v are differentiable functions of x, and if y is equal to u plus v, means y is addition of u and v, then what? Then we write derivative of y with respect to x like this: derivative of u with respect to x plus derivative of v with respect to x. Okay, so this is the rule of differentiation when our y is addition of two functions u and v. Okay, now based on this rule we have a corollary. So our main rule is here. So our corollary is corollaries. So there are many corollaries. So many means there are two corollaries. First is if y is equal to u minus v, then so if y, so rule is if y is addition of two functions, then their derivative is addition of their derivatives. Okay, and if y is equal to subtraction of two functions, then its derivative dy by dx is equal to derivative of u with respect to x minus derivative of v with respect to x. Okay, so this is a rule, or we can say it is a corollary obtained from this addition rule. Okay, we can say that this is subtraction rule also. Similarly, if we have y as a addition or subtraction of three functions, so u plus or minus v plus or minus w, then what will be the derivative of y with respect to x, where u v w are functions of x? Then it is also derivative of u with respect to x plus or minus derivative of v with respect to x plus or minus derivative of w with respect to x. Okay, so this is, okay, if our function y is addition of more than two functions, or it is addition of three functions. Okay, now let us go to the rule number 3, rule of differentiation, third rule, and that rule is called as the derivative of product. Derivative of product. So in this case, see here, if u and v are, we state this rule, if u and v are differentiable functions of x and x are differentiable functions of x, and if y is a product of u and v, y is equal to uv, then how to write derivative of y, with respect to x? And the rule is, this is, let us call it is first function, let us call it is second function. Put first function as it is and take a derivative of second function with respect to x, plus put second function as it is and take a derivative of first function with respect to x. So this is the rule of differentiation, rule of differentiation of product of two functions. Okay, so let us underline these two rule, this rule. Okay, if y is a product of two functions uv, then derivative of y is written like this. Okay, so it is very simple. Now go to the rule number 4th. Okay, fourth rule is called as a rule of rule of division. Okay, division rule. So rule number 4, rule number 4th, derivative of quotient. Derivative of quotient. Quotient means division. Okay, derivative of division of two functions. So let us again state the rule. If u and v are differential functions of x, u and v are differentiable differentiable functions of x, and if y is equal to u upon v, where v is not equal to 0, okay, then the derivative of y with respect to x is given by this rule, is equal to v. See here, I'm writing here v into derivative of u with respect to x minus u into derivative of v with respect to x divided by v square. So this is the rule of differentiation. Okay, I will make underline from this. Okay, if my function y is equal to u upon v, where v is not equal to 0, then derivative of y with respect to x is v into du by dx minus u into dv by dx divided by v square. Okay, so these are the 4 rules of derivative, and based on these 4 rules we try to find the derivative of some complicated functions. And our next point is finding derivative of functions. Okay, so find derivative of following functions. Find derivative of following functions. So that is our question, and our first function is y is equal to x raised to 4 plus x cube plus is minus 2 times x square plus 5x plus 9. Okay, so we write the answer of this question. So answer is, see here, given function is a addition of how many functions? See here, 1 2 3 4 5 functions. Okay, so we write the derivative of y with respect to x like this. So like write the derivative of first function 4x raised to the power 3 plus write the derivative of the second function 3 into x raised to the power 2 minus this is 4 into x plus 5 plus 0 because 9 is a constant function. Okay, derivative of x is 1, derivative of x square is 2x, derivative of x cube is 3x square, derivative of x raised to the 4 x raised to the power 4 is 4x cube. Okay, so this is the derivative of this given function. Let us go to the next example. Example number or second function is now, second function that I'm writing is, let us take this function now. Okay, y is equal to x cube plus e raised to the power x minus 5 times 3 raised to x in plus 15. Okay, so again write the answer or write the derivative of this function, but function y is a addition of 1 2 3 and 4 functions. Okay, so write the derivative of these 4 functions separately. Derivative of x cube is 3x square, as I have written above, 3x square. Derivative of e raised to the power x is e raised to the power x, so sign we put as it is. Okay, and minus this 5 is constant as it is, and derivative of e raised to the power 3 raised to the power x is 3 raised to x into log 3, and plus derivative of 15 is 0. So this is the derivative of the given function. Now this is the end of this lecture, and thank you for paying attention.